name's Brandon Howell. I handle technical marketing with Intersil's Digital Power Group. I'm here to discuss the ZL8801, specifically our 4-phase demo board. So here's our ZL8801 4-phase demo board. It consists of two ZL8801 controllers, our Dr. Moss power supplies. There's 4 of those, one for each phase. Our output inductors, then also our output capacitance. On the board, we've got headers for the input voltage. This is for the output voltage. I've got the output voltage connected to an electronic load. And then we have our USB to PM bus dongle. This allows the board to interface with a Windows PC running our Power Navigator software. The ZL8801 is a fully digital controller. Because of that, there's very little components around the controller itself. We have some decoupling capacitors, a few resistors to set the output voltage and then PM bus address, but really that's it. Everything else is adjusted inside the device using digital registers and then stored using our non-volatile memory. So that's a quick overview of the board, and let's jump into Power Navigator software and talk to the board and look at the load, the output voltage, etc. Now let's launch Power Navigator and start communicating with the ZL8801 4-phase eval board. So again, once Power Navigator launches, it automatically scans the PM bus using the dongle, and we've discovered 2 ZL8801 controllers, both on this eval board. One's at address 20, the other's at address 21. So I'm going to go ahead and launch the software. After I click the start button, the tool automatically goes out, downloads all the configuration settings from the device, and now I'm talking to the eval board directly. So Power Navigator has a power map that shows the controller. It has a monitor view that shows the output voltage, the current, the input voltage, the voltage monitor. I can also expand on this and actually show individual phases. So the panel on the left shows the total load current. The output voltage and the input voltage, of course, is the same. And then the 2 panels on the right here show the load current per controller. So once I enable the output, you can actually look in real time and see what the current balance is between the controllers as everything's running. So I'm going to go ahead and turn on the output. I actually have an electronic load connected to this board right now. The load is set for approximately 22 amps. So I'm actually sourcing 22 amps from the eval board. The board itself is showing an output current of 22 amps, and the current balance between controllers is very good, within about half an amp. So I've got about 10.5 amps per controller being supplied to the load. Using the GUI, I can turn the output voltage up, I can turn the output voltage down, so I will margin high. When I margin high, in this case I've set the margin to 1.3 volts. I can margin back to the nominal voltage. I can margin low. In this case I set the margin low voltage to 1.1 volt. And then again I can margin back to nominal. I can also change the output voltage in real time to something else besides the preset margins. So for example, if I want to go to 1.25, I can type in 1.25 volts. I hit the return key, and the output automatically goes to 1.25 volts. So nice feature. Even though the controllers are in current share, I can still change the output voltage dynamically with the vout command. When I turn the load current off, the load goes away, and now we're in a no load situation. I can also disable the output using the GUI. Very easy to evaluate the eval board with.